So welcome back. After 40 minutes it get disconnected. So let us start our session again. So we were dealing with the problem on circular lamina, right? So here from this point you measure and cut an arc on the perpendicular line what you have drawn. And again next you will come back to the second midpoint, a center point. So from the center point you measure this distance how much it is using compass. So come here and you cut an arc. Similarly from the center point you measure this distance how much it is and you cut an arc. So you got the point now G and C also. And now come to the third reference plane, third reference point. From here you measure this distance from here to H, how much it is, just cut an arc. And similarly from here to B, how much is the distance, just cut an arc. Okay, so now you got all the points H, G and F, the top surface, and the bottom surface B, C and D. So name all the points. A, E you had gone before. So now you have named H, G and F, B, C and D. So after this, using free hand, you will now draw an circle. It looks like an ellipse only in the second stage as well as third stage. You have to draw it using free hand. Don't use any scale. So now, as per the question, you have shifted the resting point A on 60° to VP. Okay, so this is how you have to shift the lamina for 60° to VP. After this, you will take the projection above from each point. So locus of G and H will lie on the same line, locus of A and F, locus of B and E, and locus of D and C. So after this you will extend the projection from our front view also. So from E dash, D dash and F dash, C dash and G dash, B dash and H dash, and from A dash. So then you start reading the locus. Locus of A is meeting A dash at this point. So this is our A dash. Locus of H is meeting H dash at this point. So this is our H dash. Locus of G is meeting G dash at this point. This is our G dash. And here locus of F is meeting F dash at this point. So this is our F dash. Locus of B is meeting B dash at this point. So this is our B dash. Locus of C is meeting C dash at this point. So this is our C dash. Locus of D is meeting D dash at this point. So this is our D dash. Locus of E is meeting E dash at this point. So this is our E dash. So this is how you have to solve the problem when the question is told it is resting on a point on HP and the same point is now being resting on VP also. Okay, with respect to 60°. So please try to understand the problem conceptually clear, then you will be able to trace out the problem. Don't blindly solve the question. Understand, write a rough sketch in a paper. Okay, then start doing it accordingly. So this is the first problem on circular lamina. So next we have similar kind of thing. So you have to understand, read, and then identify first, second, and third stage how it will be. So the next problem here is, it is a circular lamina of 50 mm diameter again. It is standing with one of its point on the rim on HP. So rim of the circle, circumference of the circle, everything are the same. Don't get confused. If they say one of the point is resting on circumference of the circle, it is the same. If they say one of the point is resting on the rim of the circle on HP, it is also the same. Okay, so this is also a problem where the point is resting on the rim on HP. Since it is HP, you have to show the circular lamina as the top view first and then you will go for the front view. I have shown the position of the lamina, how it will be in the video links. Okay, so don't worry. So the first stage will be similar to the last problem what we discussed. So what you do is, first you will draw XY line, name it, write VP and HP, don't forget, leave some space, take the radius of 25 mm and you draw a circle. Once you draw the circle, immediately show the dimensions. Many students are forgetting to write the dimensions. They are not taking the parallel line projections properly. Some are inclined, some are doing very congested, very nearby in between. Leave proper space and darken the views. Okay, so everything carries marks in graphics. So leave some space, take 25 mm radius, cut an arc, do the naming. So once you do the diameter dimensioning, the very next step is you have to divide the circle into 8 equal parts. So start joining the diameter horizontally, vertically, then draw the diameters in inclined versions. Between horizontal and vertical diameter, you will get the 8 points on the circumference of the circle. So here they haven't specified on which point it is resting. It is just given as point. So you can name in any order. In the previous problem they told the point A on circumference. So you were supposed to show the point A by default here. But in this case, it is not mentioned anywhere that it is point A only resting on HP, right? So you can give of any order. You can start A from anywhere, okay? So if you want to start again A from here also, you're welcome. So you can write A, B, C, D, E, F, G and H. So after this, again the procedure is same. You will take the projection above from A, B and H, C and G, D and F and from E. So after drawing, please darken the line immediately from A dash to E dash. So similarly, the observer views from bottom. A will be visible, you will write it as A dash. When you views from the bottom, B will be visible, H will be on the same line, but since he is here, H won't be visible. Write that in the bracket. And again the observer views from here. C will be visible, H will be hidden, G will be hidden, write G dash in the bracket. And again you view from here, D will be visible, F will be hidden, so you write D dash and F dash. And here you have E. When you project above, it will be E dash, which will be visible. So give the naming accordingly and darken it. So this is the first stage which is over. And then what is told? The lamina is inclined at 45 degree to HP. So now this plane which was parallel to our XY plane will be inclined to 45 degree to HP. So please draw 45 degree line. Before that, leave proper space and then draw 45 degree line. The initial point will be always A dash. So please fix A dash here and then you measure this distance and cut an arc on 45 degree line. So you will get E dash also. Darken it immediately. A dash to E dash. Then you locate these 3 points. From A dash to B dash, what is the distance you measure? Make a reference point. From B dash to C dash, what is the distance you measure? Make a reference point. From C dash to D dash, what is the distance you measure? Make a reference point. So after making reference point, write it as same points here. B dash and H dash, C dash and G dash here, and D dash and F dash as you have in stage 1. So once you do this, the procedure again is the same. Take the projections from all points and then you extend the projections from A and E, H and F, G, B and D and C. Okay, so after this you will identify the points. So projection of A is meeting A dash at this point, so this is our A. Projection of E is meeting E dash at this point, so this is our E. Projection of H is meeting H dash at this point, so this is our H. Projection of F is meeting F dash at this point, this is our F. Projection of G is meeting G dash at this point, so this is our G. Similarly, projection of B is meeting B dash at this point, so this is our B. Projection of D is meeting D dash at this point, so this is our D. Projection of C is meeting C dash at this point, so this is our C. So once you identify all the points, so using free hand you will draw the second stage top view. So it will look like an ellipse in this stage also. So this is done. So only the change in the last stage. So what is being told? The diameter at the right angles to the diameter which is passing through that point on which the lamina rests is parallel to VP. So the diameter which was resting at a particular point on HP will be now parallel to VP. So this entire diameter should be parallel to VP, which is resting on the same point. So this point A should be now tilted in such a way that the diameter here is at right angles to the horizontal one, and the point A is parallel to VP, and since the point A is parallel to VP, you should show the point A on XY line and show this diameter in this way, such that this entire diameter is parallel to VP and this diameter will be perpendicular to the diameter of the initial position. So in the last problem, they told that this point is been inclined to 60° to HP. So we took 60° to HP and identified the point A. But now the second option is they can tell, instead of giving inclination angle of VP, they are saying now the point A is parallel to VP. So when it is parallel to VP, the point A will be on VP. Along with that, the diameter will be perpendicular to the diameter of the lamina in which it was resting on HP. So you will locate the point A and draw an vertical point. Since it is just the position of a point and it is not the problem on the diameter inclination, you won't determine any beta angle over here. Okay, because the point on which the lamina rests is parallel to VP. So it is only a problem on point, not on the diameter. So be specific. So you will shift the point which was resting in HP to show that the same point is parallel to VP. So on XY line, leave some distance and fix the point A. So now we have fixed this point A. This point A and this point A both are similar. So we'll fix this point A, and from there you have to reconstruct the second stage. Okay, so to reconstruct the second stage, you have to get all the points. So to get all the points, first try to get the opposite point. So in order to get the opposite point, you have to draw a line. Here it is an horizontal line, but since A is located here, you have to draw a vertical line. So draw a just exactly perpendicular line. Measure the distance from A to E, how much it is. Just cut an arc. So it will meet somewhere on this vertical line. So name that as E. So you got the points A and E. So remaining points you need. So what you have to do, similarly in the last way, you have to draw these three positions, 1, 2 and 3. So what you do, you just measure from A to this point how much it is. Using the compass, just make an arc and keep the reference point. And similarly you measure from A to this center point how much it is and just make a reference point. And from E to this distance how much it is, just make a reference point. So after making the reference point, you have to draw the line perpendicular to the line AE, okay, or draw the line parallel to our reference plane. So we will draw the parallel line from both. So you can extend also until you complete the construction. So just extend a parallel line to our reference plane such that it will be perpendicular to AE also. So after you draw these three construction lines, so what you do is, from this point you measure the distance how much it is for H. Okay, so from this point you just cut an arc on this parallel line to XY line. It will meet somewhere, so you name it as H. And again come back. From this point you measure B how much it is on the same line. Keep one end of the compass and cut an arc. It will meet somewhere, so name that point as B. Similarly, come to the second midline here. From the center, you measure this distance. From the center to G, how much it is. Keep one end of the compass here and just cut an arc. on this line what you have drawn. So it will meet at some point, name it as G. And again from this to C, both the distance from center to C, from center to G will be same only. But still you measure from center, so center to see how much it is. Keep one end of the compass here and you cut an arc. You got the point C, name it, and come to the third line, midpoint. From here to F you check what is the distance is, you measure and you cut an arc. Similarly from the midpoint to D, how much is the distance, you measure and you cut an arc. So you got all the points now, A, B, C, D, E, F, G and H. So now using smooth hand, a free hand, you just draw the ellipse. Okay, so now you have shifted the second stage of the lamina to the third stage such that the point A is parallel to VP, which was resting on HP is now parallel to VP, and hence our diameter gets changed from horizontal line to the perpendicular line. So once this is over, you can extend the projection line from C, from D, from E, F, G, H, right, from all the points. After that, extend the projection from the front view also. A dash, B dash, H dash, C dash, G dash, D dash, F dash and E dash. And finally read out the locus. So locus of C is meeting C dash at this point, so this is our C. Locus of D is meeting D dash at this point, this is our D. Locus of B is meeting B dash at this point, this is our B. Locus of A and A dash is on same XY line, so this will be our A and A dash. So write this as A dash. And then locus of H and H dash is meeting here, name it as H dash. Locus of G and G dash is meeting here, so this is our G dash. Locus of F and F dash is meeting here, so this is our F dash. Locus of E and E dash is meeting here, so this is our E dash. Locus of D and D dash is meeting here, so this is our D dash. And locus of C and C dash is meeting over here, so this is our C dash. So this is how you have to solve the problem when it is resting on a particular point on HP and the same point is parallel to VP. Okay, in the previous problem, the same point was inclined to particular angle to VP and hence we solved in this way. But in this case, they haven't given the inclination with respect to VP, but they have described that the same point is parallel to VP and hence you have to show the point on XY line and construct the top and front view of the lamina. So this is how you have to solve the problem when it is associated with the point resting on the circular lamina, on the circumference or on the rim, both are the same. So one more type you have to understand, when it is a problem on the diameter and not the problem on a point. So if it is a problem on the diameter, then you have to determine the apparent angle. So this is the case. So it is a circular lamina of 50 mm diameter. So it rests on HP such that one of its diameter is inclined at 30 degree to VP and 45 degree to HP. Draw its top and front view in this position. So it is a direct question. They have given the inclination both with HP and VP, but it is a case of diameter problem. Read the question. It is a circular lamina of 50 mm diameter. Rest on HP. How it is resting? Such that one of its diameter is inclined at 30 degree to VP. So one of the diameter is inclined 30 degree to VP and the same diameter is inclined to 45 degree to HP. So you have to fix which diameter you are taking. Obviously, you leave some space. Since it is a problem resting on HP, you will start with the top view and then come for the front view. So you will take a center point, you will take a radius of 25 mm and you draw a circle. Once you draw a circle, you know how to divide that into 8 equal parts. So you will divide that into 8 equal parts. They are not specific about the naming of the points. So you keep of any order of naming, either A, B, C, D, E, F like this, or A, B, C, D, E, F, G, H like this, and show the dimension. But the case is the diameter has to be inclined to VP and HP. So when you project, you see that you are projecting the diameter, right? So obviously when you take the projection, you are projecting the diameter from A to E. So the same diameter surface as the front view will be inclined to our HP as well as VP, because they have told the diameter is inclined to 30° to VP and 45° to HP, right? So first initial stage is the same. You will name it. After dividing into 8 equal parts, you will take the projection above, then the observer views from the bottom. A will be visible, you will write A dash. B will be visible, you will write outside. H dash will be hidden, so you will write it in the bracket. Again C will be visible, H will be hidden, so you will write C dash outside and G dash in the bracket. And again when the observer views from here, D will be visible and hence you write it as D dash. F will be hidden, you will write it in the bracket. And again E dash, E will be visible, you will write it as E dash. So after this you will join with a thick line, so then you will get the front view and the top view of the lamina. So true shape is always obtained in the top view when it is resting on HP. So next, the second stage, what they have told, now the diameter is inclined to 45° to HP. So this is the diameter. So the same diameter we have projected above as our front view. So when we shift the front view to 45°, it is nothing but we are shifting the diameter to 45° to HP, because this is the projection of the diameter what we have taken. So leave some space, name this as A dash. So from A dash you take 45° to HP. So after you take a 45° line, you measure the distance from A dash to E dash how much it is, and you cut an arc on 45° line. After this, kindly check the naming. From A dash to B dash how much it is, make it a point. From A dash to C dash how much it is, make a point. From A dash to D dash how much it is, make a reference point. So after you make the reference point, kindly name it B dash, H dash, C dash, G dash, D dash and F dash. Okay, so you got the namings now. Dark it immediately. So this is the front view of the second stage. So after that the procedure here is again same. You will take the projection down and you extend the projections here. So when you extend the projection here, you will read the locus. So locus of A is meeting A dash, locus of B is meeting B dash over here, locus of H is meeting H dash over here, locus of G is meeting G dash over here, so locus of C is meeting C dash over here. So name it A, B, C, H and G. And similarly locus of F is meeting F dash over here, so name it F. Locus of D is meeting D dash over here, name it as D. Locus of E is meeting E dash over here, name it as E. So once you get, sorry it got disconnected. Okay. So once you name all the points, you will join using freehand. So you will get the second stage of the top view, but it looks like an ellipse. If you have constructed properly, it will look exactly like an ellipse. So what is the problem now? In the first stage, the diameter was inclined to 45° to HP, we did it. And in the second stage, the same diameter is inclined to 30° to VP. So which is that diameter? This is the diameter what we have projected above. So the same diameter now has to be inclined to 30° to VP. But what's happening here? If you take any point, the point location will be the same. No need of determining the apparent angle. But when it comes to the problem on diameter, You can see the true length in the first stage, and in the second stage the lamina looks like an ellipse and the diameter distance has been shrinked out. So you can just get the apparent length of the diameter in the second stage. You cannot get the true length of the diameter in the second stage, and hence there is a need to determine the apparent angle beta. So for that, what we have to do, the procedure is same.
Your voice is breaking.
Just a second. Am I audible? Hello? Hello? Am I audible, please?
Yes, ma'am.
Yes, ma'am.
Okay. So now, since it is a problem on the diameter, you get the true length in the first stage and you get the apparent length in the second stage, because here the lamina is inclined to particular angle. So you cannot directly go and shift the second stage to 30° to VP. You have to determine the apparent angle. So the procedure is same as usual. What we do, first we take 30° to VP. You can take either 30° in this way or 30° in this way, depending upon the availability of the space. So here we have taken 30° to VP. After that, always you have to take the true length from the first stage. So measure the diameter length here. So before going, name this as E1 so that it will be helpful for you to identify two different points. So you measure from A to E1 how much it is. Leave some space on 30° line. So this is our 30° line. Okay, so this is our 30° line. On 30° line, you fix a point A. So from A, you measure the true length exactly how much it is, A to E1, and you please come back to 30° line and you cut an arc. So it will meet somewhere on the 30° line. So name that immediately as E1. So A and E1 will identify the true length of the circular lamina. So once you name it as E1, write this as the locus of E. So once you are done with locus of E, come back to the second stage. And here you please measure this distance A to E, how much it is. A point is fixed already, don't change the point. So let the point A be the same. You measure the true apparent length of the diameter from the second stage. Go back to the same position of A and try to cut an arc. So before that, you see that you have drawn the locus of E for a particular length, because you should identify where it cuts. So measure the apparent length, come back to point A and cut an arc on the locus of E what you have drawn. It might meet at some point. So please name that immediately as E. So once you name it as E, join the diameter AE. So this is our apparent diameter of the second stage. So once you got the apparent diameter of the second stage, extend the same line back to our XY line. So this is our XY line. So when you extend, so this is the inclination angle, apparent angle. So please measure using the protractor and show how much you are getting. Beta here it is about 45°. Always the apparent angle will be more than given inclination angle. If you are getting the apparent angle less than the given inclination angle, then you have gone wrong somewhere. Be careful. So after you draw the diameter over here, so then you have to shift this entire second stage to our third stage top view. So for that the procedure again is the same. I have told you how you have to do it. So again what you will do, so now you got the point AE, you have joined already. So this AE you know. So these 3 points you have to locate. And again these 3 points you have to locate. So all these 6 points are lying on these 3 lines. So first line, second line and third line. So what you do now is you have to identify this point and this point. So now from A to this, what is the distance? You please check and name it. Okay, and similarly from A to center point, what is the distance? You measure and make an arc or reference point, whichever is convenient to you. And again from A to this point you can measure, or from E to this point you can measure. So whatever convenient, from A to this you measure, keeping one end of the compass here, you measure the distance and make a point. So after making the point, you just try to draw perpendicular line from all the 3 points. I have just shown you roughly. Please draw perpendicular lines from all the 3 points. So once you have drawn perpendicular lines, measure the distance from this point to H what it is, come back to the perpendicular line what you have drawn, and you just cut an arc. And again from this point to B you measure how much it is, come back to the reference point and you cut an arc. So you got the point now B and H. Name it immediately or else you'll get confused. So now come to the center point. So from center point you measure from center to G how much it is, you cut an arc. And similarly from center to C how much it is, you cut an arc. So you'll get the point C and G. And again come back to the third line. So from the third line to F, what is the distance you measure? Come back to this perpendicular line what you have drawn, and you measure the distance from there to F and you cut an arc. And similarly from this point to D you measure how much it is. From this point again you cut an arc. So you got now all the points. A and E was there before, so now you have traced out B, C, D here, and you have traced out H, G, F over here. So then using freehand, join all the points A to B, B to C, C to D, D to E, E to F, F to G and G to H. So now we have shifted the diameter of the second stage circular lamina to the apparent angle 45° as required. So after you do this, you have to extend the projection from each point. Projection from B, projection from C, projection from A, projection from D, projection from H, projection from E, projection from F and projection from G. Don't leave any points. If you are dividing the circle into 12 parts, you have to take the projection all above for 12. That is still time consuming, so it's better if you go with 8 points. So after this you also extend the projection from A dash, B dash and H dash, C dash and G dash, D dash and F dash and also E dash. So once you are done with this, using freehand you can draw a smooth curve. So if A to B, B to C, C to D, D to E, E to F, F to G, G to H and H to A. So this will show you the last stage front view, how does it looks for the inclination of the lamina, the diameter one for the apparent angle. So please you can show here also beta is equal to how much. Along with that in a box you can write beta is equal to how much what you have calculated. So this is how you have to solve the problem in circular lamina when it is of diameter based problem. So here in this case it was a problem which was resting on HP. If it comes the given circular lamina is resting on VP, then you have to start up with the front view, take the projection down for the top view and then take the inclination with respect to VP first and then show the front view how does it look. And if it is a diameter problem, then you determine the apparent angle alpha whenever you have the position of the lamina resting in VP. And if it is an apparent angle problem, you have to determine alpha, not beta. Some students still have confusion related to that. Okay, so kindly be sure enough. So this is an simple problem. I haven't added this question. So here you can see if it is a circular lamina of 30 mm diameter rests on VP such that one of its diameter is inclined at 30° to VP and 45° to HP. Draw its top and front view in this position. I haven't shared the video link to this. You can solve by your own. I'm just explaining you. Okay, so it is a circular lamina of 30 mm diameter which is resting in VP. So whenever it is resting in VP, you have to start up with the front view and then come back to the top view. It is totally reverse. Okay, please understand the question. So when it is an lamina of 30 mm diameter in VP, please draw and circle in the front view by taking the radius of 25 mm. So it is 30 mm, means the radius will be exactly 15 mm. So take the radius of 15 mm and draw and circle. Once you draw the circle, they haven't specified any point resting, so you can name it in any order. So divide the circle into 8 equal parts. So you can name A, B, C, D, E, F, or A, B, C, D, E, F, G, whatever. But since it is front view, name it as A dash, B dash, C dash, D dash, E dash, whatever it is, for 8 equal parts. Then you take the projection down. Kindly leave some space. Don't draw the circle very near to XY plane. Okay, so take the projections down. So after you take the projection down, whenever the problem is resting on VP, the observer views from the top. So when he views from the top, the projection of A dash is visible, so we will write it as A. So when the observer views from top, so this is our H dash. H dash will be visible and B dash is on the same line, it will be hidden. So you will write H in the bracket B for our top view. Similarly, when the observer views from top, G dash will be visible and C dash will be hidden. So you will write G outside the bracket and you will write C within the bracket. And next again you see the observer is viewing from the top. So when he is viewing from the top, F will be visible and D won't be visible. So you will write F outside and D in the bracket. And similarly, when he views observer from the top, E will be visible, so we'll write it as E. So you now identified all the points right from A to E. So you will darken this. So once you darken this, you know the namings what I told right away, so you have written it. So after this, what is the question given? So it is a problem on the diameter. So the diameter now is been inclined to 30 degree to VP. So whenever it is a problem on VP, you have to take the inclination of VP first and then HP. So you leave some space. We have taken the projection of the diameter already as our front view, which is lying on XY line. So now we shift this front view to 30 degree to VP. So you leave some space and fix a point here as A. So after you fix a point A as A, you have to take 30 degree to VP. So once you take 30 degree to VP, you measure this distance from A to E is how much, and you just cut an arc. So once you cut an arc, you got this distance exactly. So you kindly darken it. So once you darken it, you measure A to H is how much, and you just cut an arc, and again go from H to G how much, you just cut an arc. So from there again G to F is how much, you cut an arc. So you got all the points here. So once you get all the points, dark it immediately, don't forget. So once you have done the naming of the top view, so you will take the projections above from each point. So after you take the projection above from each point, you have to extend the projection from the front view also. So you will extend the projection from A dash and E dash, B dash and D dash, C dash, H dash and F dash, and G dash, right? So then you start reading the locus. Everything is same, only the thing is it is the reverse with respect to the previous problems. So you read the locus of A and A dash. It will meet at a particular point. Locus of B and B dash. Similarly, locus of H and H dash. And again, locus of C and C dash. Locus of G and G dash meets here. So name it as A dash, B dash, C dash, H dash and G dash. Similarly, locus of F and F dash meets here. Locus of D and D dash meets here. Locus of E and E dash meet at this point. So you now got all the points. So once you get all the points,